you'll be eating less because your body will be getting the nutrients it needs. Have a smoothie with 3 scoops of protein and throw in some fiber and throw some water in there and throw your fats, which we'll talk about here in a second, and you won't want to eat for hours. And you won't have to fight it. I hate willpower. I have no willpower at all. I hate the word willpower. Because that means to me, there's this fight going on inside. Yes, no, yes, no. How healthy is that going to be? Right? It should be easy. It should be easy. You should just flow naturally. You have your protein, you have your smoothie, you're not going to want anything. Cake? I don't want a cake. Doesn't even look good. And that's what will happen, because as you eat, you can't believe it, right? Shocking. Protein kills your sugar cravings. And your sugar cravings are caused by protein deficiencies. Protein will kill your sugar cravings. And you say, well, I just had a steak, I still want dessert. Guess what? You didn't have enough protein. Because when you have enough protein, it will shut down your sugar cravings. It'll shut down your, and I don't want to digress too much, although that seems kind of silly to say, doesn't it? Your digestive system is shut down by sugar. The dumbest thing you could ever do after dinner is have a cup of coffee and a piece of pie, because that will shut down your digestive system, especially if you've had protein, because then the protein will just sit there. That's a dumb thing to do. So have your coffee and pie 2 or 3 hours later or even before. Just another one of the silly things we do as a culture. All right, chapter 2, fats. I love talking about fats, because fats are the most misunderstood chapter in the whole handbook of good nutrition. Fats are so important for so many reasons, and I knew I'd get to use this transparency. Honey is just sugar. I mean, there's some few nutrients in there. I wouldn't mess around with honey. You don't need it, but vinegar's great. Vinegar's great stuff. Yes. Apple cider vinegar is awesome. What's that? In terms of a fat? Poach it. If you want to cook with, the best cooking fat, I'll talk about this in a second. The best cooking fat is coconut fat. Coconut oil. Virgin coconut oil, great for the thyroid, great for the immune system, tastes great, stable. How do I turn this on here? Okay. So, pretend that's a cell. Remember, a cell is a blob. Well, just a little blob. You can fit 64,000 red blood cells on the head of a pin. It's a little blob. But inside this little blob, there are trillions of atoms. Trillions. You know, we live in this age of economic inflation where trillion doesn't mean anything anymore. But trillion, that's a ridiculous number, folks. They're not a trillion. There's 100 trillion atoms in a cell. How long do you think it would take you to count to 100 trillion if you count one by one?
3 years.
30 years, 100 years, 1,000, 3.3 million years. If you had to count, that's how much 100 trillion is. And you have 100 trillion atoms flowing around in each one of these cells, of which you have 100 trillion of them. You don't want to even go there. In the middle, you have DNA, nucleus, and then you have DNA in the middle. The DNA gets turned into protein. Is this good? Are we good here? Chicken scratching here? The DNA gets turned into protein. People used to say, oh, the gene controls everything. Genetics control... Did I mess up? You guys laughing at me behind my back? That's not very nice. All right, whatever. The DNA gets turned into protein. So they used to say, well, DNA is everything. They call it, by the way, they call it the central dogma. That's what it's called, the central dogma. Next time your doctor says it's in your genetics, or you say it's in your genetics, you're referring to something called the central dogma. What's a dogma?
Belief.
A religious belief that's held on faith. That's what the DNA theory is, the genetic theory is. It's the religious belief that's held on faith. It's not true. It doesn't work. Because people who have no genetic propensity for something get something, and vice versa. And there's only, you got 150, 200,000 proteins in your body, and there's only 25, 30,000 genes. We have the same genes as a monkey or an earthworm for the most part. So clearly there's a problem linking the two, unless you know an earthworm. You know, an earthworm has the same DNA, with 90+% the same DNA as you do. In any case, essential fatty acids work here to help the protein come out. This is so important. I'm glad. That's one of the main reasons I wanted this transparency, because I want you to get this. Essential fatty acids work here genetically. Genetically. Fats work genetically, folks. That's powerful stuff. You turn on your genes. For women, EFAs act like estrogen. If you have hormone replacement therapy, if you're contemplating hormone replacement therapy and you're not on EFAs, you're crazy. I've seen hot flashes disappear. Disappear when you're on EFAs. And oh, by the way, here's how you can tell you have a fat deficiency. Remember, how do you tell you have a protein deficiency?
Sugar.
Sugar, right? Crave sugar. How do you have fat deficiency? You crave fat. Your body needs fat. And you will go get fat wherever it is. And in turn, you will get fat. Because your body can't process that. Your body can't process that. It's looking for EFAs. Now, there's a couple other things that happen with essential fatty acids that nobody talks about. You have hormones in your body. You have, let's do this right. You have insulin, right? That's a hormone. We'll talk about insulin here in a moment. You have thyroid hormone. I'm just throwing out hormones here. You have your sex hormones, testosterone, progesterone, estrogen. All of these hormones work by connecting into little ears on the outside of a cell. I'm talking to you, the words are coming out of my mouth, they're going into your ears, and you're getting a message. Well, cells do the same thing. But instead of words, and instead of ears, they have hormones and receptors. That's what a hormone is. It's a communication molecule. It's a word. It's a command. However, there are other hormones that don't go into the ears, but simply sit outside the ears. And they make the ears more or less receptive to the hormone. They're called master hormones because they control all the other hormones. If you're a biochemist, they call them mycosinoids. You may have heard of prostaglandins, for example. Some of you may have heard of thromboxanes. Those are all examples of master hormones. They work on the outside. Is my chicken scratching here good? Are you guys okay with this? So that is kind of a mess, but you have hormones sitting in the receptors, but on the outside, you've got master hormones that control all the receptors. Well, those master hormones, those eicosanoids that control all the other hormones, the effect all the other hormones have, come directly from essential fatty acids. Directly from essential fatty acids. Don't worry about DNA yet. Did that make sense? I'll get you a second. Hang on a second, I'll get you. I want to make sure everybody understands this. These master hormones are made from essential fatty acids, eicosanoids, these chemicals that help all the other hormones work. That means under deficiency states, none of your other hormones will work correctly. If you're not on EFAs, you're deficient. That means none of the hormones will work correctly. Should I go over that again? Does that make sense? You want me to go over it again? Okay. Guys, you're getting some good chemistry here, by the way. This is some good stuff. The outside part of a cell, by the way, remember how small these things are? Well, there's hundreds of thousands of ears, hundreds of thousands of these receptor sites. And all drugs work at the receptor site level. I don't want to get too much into digression here, but so these are the ears. They're called receptors. The hormones sit in the receptor. In some cases, they actually go into the cell, but we won't complicate things. The hormone sits in the receptor. You get a reaction, like a doorbell ringing. They used to say the lock and key. You did warn me about that, Don. I know that. Okay? So does that make sense? The hormone sits in a receptor and you get some kind of action. Well, on the outside of the receptor, you have other chemicals that make the receptor more or less receptive.